Welcome to another episode on my monorail from fischertechnik, controlled by a robo interface connected via USB to BeagleBoard Classic running Ubuntu Linux. Everything programmed in Python. Last time I did attempt to recreate the dragging actually that I experienced the time before that, and unfortunately I didn't manage. So then I started to more or less rebuild the carriage, because in this situation it derails here because the wheels are now in an angle. Given the way that it is connected here, which is not too robust, that failed. Another thing is that this connector failed as well, which I hope I restored, but I'm still eager to reconnect, to reconstruct it so that this angle is being saved, but that the wheels are actually like this instead of like this. So the big question is, how do I do that? And one thing is, well, you remove the wheel, and then you have to remove this part as well, which is not a problem. But then next part is, do you do it like this? Well, it seems obvious, but it turned out not to be obvious at all. So let me try to do it like this. Oops, small parts are hard to come by, so with wheels like this, and this exactly well perpendicular to this, I have to figure out how to do it. So I think I should put it in like this, and then put the wheel somehow like this, and that may seem logical, except that when you balance it, and how come it doesn't balance now? If you do it like this, it balances like this. If you put the wheels like this, it goes wrong. So that is a nice question. I think I will first put all the wheels like this one, and then see how it balances, and then find empirical the best way. How it will end up, not a clue actually. Really not a clue, but this doesn't sound very promising, to be honest. Because a wheel is a wheel, and how it rests, I don't know. But it seems unlikely to me that it changes the whole balancing. So Yeah, let me test that. So now this is absolutely unbalanced. The question is, how can we get it balanced? Or more appropriately, can we get it balanced at all? Well, never mind the wiring for now. And let's take this one off. Let's try to keep the carriage in one part, in one piece. And then instead of the 60 degree part, let's use let's see which angle this is, a 30 degree. However, I am kind of worried that even that won't work. So I should put it like this. Alright. First this one. So, yeah. Let's put this wheel in. Same angle. And putting it like this. Forget about the motors and the rest for now. Let's just see if it balances. Well, that says enough. Then I could take the second or this piece of balance. Well, that doesn't work at all, so no use to put that one on. So then what? Well, this kind of hangs on, and this is a 30. The 60 doesn't work at all. So how do I balance it that it doesn't drop off? An even lesser angle, because with 15 degrees. And then of course I have to keep in mind that I also have to deal with the power rod and the ground rod. The power rod isn't that much of a problem, well, or at least it shouldn't be. So let's get this one on again. Well, this makes contact. On the other hand, this has to be way longer than it is now, because now it's at the longest, and this belly, yeah, okay, it touches a little bit, but the angle is way off. So, and the wiring has to be changed then. So this is no solution either. Right, next attempt, 15 degrees. So now I have changed the angle to 15 degrees for these wheel sets only. And what I should keep in mind is that they are at the same height as this one, because if this is the right angle, this last third block goes here. Anyway, let's see how this balances or not. And then I have to keep in. Oh, you're joking. This is not balanced at all. So even with this, it's not balanced. So how does it balance? I think that if I put it closer, it balances better. Alright. This is next to horizontal. So if I go back to 60 degrees in the same manner, what will happen then? That's a nice idea. So let's see how we do that. This is the way it writes, and this is the way the angle will go. Again, some experimenting. So this one will go like this. And again, it has to be the same height or something like that. So more or less like this. And as close as possible. But this will give a problem, I predict. Kind of predict. So how is this not equal? Because of, right, this is not correct. They have to be like this. Even then it doesn't feel like equal, but let's try anyway. Well, it is kind of balanced, but something in the carriage is now totally off. Yeah, now this is pushing them away a bit. And once again, experimenting on the go. Not really scientific, because then you draw and you calculate, but right now I don't care about that. So I really think I should go for another angle. Yeah, not a 60, maybe the 30. But this is, but it is a combination anyway of the angle and the distance. And this isn't a good one. Anyway, that's learning. Alright, two wheels mounted. This is the third wheel, which should be here. both on 30 degrees, kind of balanced, in the respect that they won't derail, hopefully. So let's see how this works out. And I'll do so with my own program, not with the diagnosis. And then the idea is that things really do work. And as yet, right, that means that I have not enough contact here. That is one. And this is two. Very, very important to have contact if you want to do something. And this is so-called fine-tuning. Alright, let me add some weight. Doesn't help. So how come this doesn't work as I intended? Well, the odd thing is, as you can see here, there is a slight movement. It certainly has drag, I mean. So, yeah, this should be pushed a little bit higher. Oh, by the way, you notice the absence of the third probe, but that's on purpose. Because since this works, it has a signal from the bar, from the rod. Just a slight touch, but I'm missing the drag again. Then the other question is, does it derail right here? Let's find out. So I'm moving the camera a bit and let's just roll it. Oh yeah, it will derail at the moment. Now it won't. Yeah, well, that is clear. pushing it. Well, it won't reveal now, so that's a happy thing, a fortunate thing. But on the other hand, that's all I can do now. It doesn't run consistently, which I don't like. So, all things considered, let's see how it walks, not walks, how it runs in this position, because now you see it from a different angle how tilted it is. And I first want to run the diagnosis, and here we go again, and then again. No, I have to select this one, and this goes quickly over here. Now it's active. So what do I need? Motor 2 probably. But it doesn't do a thing. So let me open the source and scroll down. What does it do? Motor 2. Yeah, right. Well, here you see it on the oscilloscope. I should change the height, the distance between the lines, but you can see it is clearly pulse modulated. This way is different once again, but this way it clearly is, and it's 9 volts. So it's 5 and 5. Well, 5 and 5 actually. So 9 volts is correct, but it doesn't do a thing. So let me move it by hand and try again. Not really. Alright, what I'm going to do is put it on 3. Move it. Now it runs. Faster, which is no use because it stands still. Despite everything, it stands still. Up and right. If I want to see something happen, right. Here I see something. But here it's tilted too much. So, despite it running at speed 4, the right, now you see something happen. The ground wheel was not touched. So let's go further. Or at least that's the idea. So pulse modulation, as you can see right here, not exactly what's happening. can we do that? Quite unfortunate. Right. You're thinking, balance is okay, but it still won't run. And only a little bit of drag. So even in this new balanced situation, things don't go exactly as planned. And as you can see on the oscilloscope, it is now full speed, but this is not exactly full speed. And only a slight touch makes it run. Oops. So alright, let's switch to my own software again. Running. Well, this is totally full speed, just doesn't look like it. And from the previous segment you have seen what the angle is now. So the point is now not friction. The point is clearly that there is something with the contact that prohibits it to run nicely. And the very question is, what is that? Well, I will of course use the third wheel in the middle, not the fifth wheel on the wagon, but yeah, to say that this is a nice solution or the solution. Maybe I should add some more weight, but well, ouch, that's not the intention. But adding this counterweight already has proven not to be the solution, or maybe it's a solution, but then again it goes faster and slower and faster and slower in speed. Well, right now I don't have a clue. So some attempts being made to improve it. Did it work? Not convinced. For now, thank you for watching. If you like this video, please give it a thumbs up. Subscribe to my channel and leave a comment if you want. Also follow me on Twitter, retweet and like, follow me on Instagram and like. Please donate to keep the videos coming to you. See the start of this video for more information on my website, and this is going to be continued. For now, bye bye.